All right, in this example, we're looking at negative indices, and you've actually seen negative indices before when we did scientific notation. So remember I said when you are dealing with a very small number, you have a negative power. Okay, so you can see here we have the key idea is your base to a negative power, so a to the negative m is the same as 1 over a to the m. And if you were to put that into your calculator, so if we were to do just 10 to the negative 2, it's a small number. The number is getting smaller as opposed to 10 squared, which is getting bigger. So you should know 10 squared is 100, but 10 to the negative 2, if we follow this, is 1 over 100, which is 0.01. Now, the reason we do them in what we call positive powers is so that it's just good maths, I guess. So it's, in English you have certain rules for grammar and so forth. So in maths we tend to just write numbers to the positive power. So here are the two rules. So you may have already written these down, but it's a good idea to write them down again. And we've got just two examples here. So 2 to the power of negative 3 is 1 over 2 to the power of 3. So basically we've turned it into a positive power. But because the base is a number, which is 2, we can actually work out what 2 to the power of 3 is, and it's 8. So 2 times 2 times 2 gives you 8. Now, if you had 1 over a negative power, okay, so you can see the rule here, we get 2 to the power of positive 3, which is just 8. Now, a good thing to do is to work through this table here. So I'll just scroll up. Okay, this is just taken from your textbook. So due to fees, an initial bank balance of $64 is halved every month. Wouldn't that be terrible? It doesn't really exist, but we are doing our numbers as positive indices. So our base is 2. Okay, so if you wanted to, you can say, all right, here we have 2. I know 2 to the power of 1 is 2. I know 2 to the power of 2 is 4. Yeah, I can see a pattern here. 2 to the power of 4 is 16. 2 to the power of 3 is 8. So I can see my powers are descending as these numbers are getting smaller. So 2 to the power of 0 is 1. So you should know anything to the power of 0 is 1. But what happens when we get to these fractions? Well, you can still write 1 over, but the 2 you can write as a power. So there we have 2 to the power of 1, 1 to 2 to the squared, or 2 to the power of 2, then 1 to 2 to the power of 3. And in this last row, we're writing them as positive and negative indices. So basically right up to here, where we have 2 to the power of 0, they're all positive, yeah? Okay, so so that was a 2. I mean a 3. There we go, 2 to the power of 5. So it's only these last two that we actually have to write as a negative index. So this one here, well, this one is negative 1, this one is negative 2, and this one here is negative 3. So what do you think would happen if we kept going? So first question here is, what would be a way of writing 1 over 16 using positive indices? Okay, it's depending on what your base is. So let's keep the base as 2. So 2 to the power of what gives you 16? We can see here 16 can be written as 2 to the power of 4. And that as a negative index is 2 to the negative 4. So you can see if we kept going here, we would have 1 on 16. Okay, and then we'd have those two values. And basically your number will still exist. Okay, so the number still exists. It's just getting smaller and smaller and smaller and smaller and smaller. Okay, so it's always there. It always exists. It just keeps going. And we say it keeps going down to keeps going to infinity. Okay, if it's very big, or well, we can go to negative infinity if we're got negative numbers. But these ones here would be going to 0. Okay, so if we're going bigger, 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 it'll go to infinity. But here we're not dealing with negative numbers, we're just dealing with positive numbers. So it'll gradually head towards 0, but it will never reach 0, if that makes sense. Think about it. Okay, let's move on now to some questions. Okay, so express the following using negative indices. So everyone, I want to do these. I'm going to give the method students some harder ones to do just because they will be dealing with negative indices, and having that extra practice will be very valuable for you. So it's a good idea to have the index laws in front of you. Remember, they're the key ideas that we had previously. Here. Okay, so they're written very simply for you. Okay, so the first one, x to the negative 5, we just write as 1 over x to the power of 5. 1 over a to the power of 4. Okay, so straightforward. The next one, 2m to the negative 4. Now this power is only associated with the m, so the 2 goes up the top and the m goes on the bottom. So what do you think d might be? What goes on the top and what goes on the bottom? We have the 3y power of 7. All right, what about e? Now we've got a few values here. We're 3a squared, b to the negative 3. The b is the only thing with a negative power, so we've got to put 3a squared up the top and the b cubed down the bottom. Okay, and let's have a look at G. We'll skip F for now. I'm not going to do every single question. So anything that has a positive power, so 10 has a positive power, so we'll put that up the top. And Y has a positive power, so we'll keep that up the top, Y 5, and then Z. And then anything with a negative goes on the bottom. And remember that power changes to a positive. Now I'm going to skip a few because I know the ones down the bottom, I, J, K, are a little bit harder. So here we've got a fraction. Okay, so you can, if you like, do this in 2 steps. We'll keep the 1/3, and basically there's a invisible times in between each pronumeral and the coefficient here. So this is 1/3 times p to the negative 2, and you don't have to do this as I'm doing it, but it's just a good way to show you. So the p is 1 over p squared. The q, okay, q is on the numerator because it's a positive power. You can write that over 1 if you want, you don't have to. And the r is up the top as well. So anything up the top stays on the top. So we have q, it's a q, not a 9. So we have q cubed on the top and 3p squared on the bottom. Now you didn't have to write all this, okay, so eventually you'll know that the 1/3 means that the 3 is on the bottom and the 1's on the top. So let's have a look at 1/5. I'm still going to keep that 1/5 here, but everything else I'm going to do just in one fraction. So the d squared is on the top and the f to the power of 5 is on the top also, but the e comes down the bottom with a positive form. Okay, so when we multiply these, we're left with d to f5 on the top and 5e to the power of 4 on the bottom. All right, have a go at k without me explaining it, so you can pause. All right, so I'm going to again write that fraction first and then do everything else separately. So the u is on the top with a w and the v is on the bottom with a positive power of 6. And then we're left with 3u squared w7 over 8v6. Okay, so hopefully that's what you got. All right, let's keep scrolling. Okay, so here we're going to write them with positive indices. So in your key ideas, this was the second example you had. So basically, this just becomes x squared. Okay, so we're basically flipping the fraction. Oh, not flipping it, because we're not going to flip it here. This x comes up the top as a positive. Okay, so if it's negative on the bottom, it comes up the top as a positive. So this one here is 2y cubed 4m 7. So you can see that the number stays. It's just the prenumeral that changes. This one is db4 d3 and so on. Oh, let's do G, because G is slightly different. So here we have 4. I like to write the letters in alphabetical order. So we have A cubed, B4, but that 3 has to stay down the bottom. Okay, because it already has a positive index. Okay, its positive index is 1, but we don't put that up the top. Otherwise, it's going to be 3 to the negative 1. All right, so see how you go with them. You can always check your answers with the solutions or ask for help if you need some help. One last question. Let's scroll to question 3. Okay, so here we're going to write them as with positive indices. So A and B are going to be positive anyway. So I'm going to start with C. So C here we have, we'll do the brackets first. So keep the 2. Now remember, when you've got a power outside your bracket, so a power to a power basically, we're going to multiply. So it's x to the negative 21. And the x has got the negative power, so the 2 stays up the top, and it's x to the negative 21. Let's have a look at something that might be a little bit harder. Oh, let's just do E, because people always forget about everything inside the bracket. So remember, the power outside the bracket is for everything inside the bracket. So we can't forget the 3 squared and then t to the negative 8. So that becomes 9 over t to the power of 8. So these are slightly harder. Did you notice the error I made? I might just point it out in case you didn't. I accidentally put a negative in here. Okay, so hopefully you picked that up. Make those changes on your thing. I was just checking the questions to see if there are any that we couldn't do, and then notice that that should have been a positive power, not a negative power. So you just want to make that change. See what happens when you rush, you make errors. Okay, so let's have a look at some of the harder ones. So down here, let's start with H. Okay, so the negative 8, that number is negative 8. There is no negative power there. Okay, so we don't have to change anything with that negative 8. It's not the power that's negative, it's the 8 that is negative. Then we have x, 5 times negative 3 is negative 15. And then the negative 8 over x to the positive 15. Okay, let's see what else we can do. Let's just skip to J. So the 3 is to the negative 4, and the H is negative 3 times negative 4. It's actually positive 12. Okay, so don't let that confuse you. So the the H12 stays up the top. That's the positive power, but the 3 to the negative 4 is a negative power, so it has to come under the bottom as 3 to the power of 4. So we have h to the power of 12. Now you should be able to do 3 to the power of 4. Okay, so the easiest way to do that, remember it's 3 multiplied by itself 4 times. So if I was to pair these and pair these, 3 times 3 is 9. 3 times 3 is 9. And what is 9 times 9? It is 81. Okay, so instead of doing 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is, oh my gosh, I don't know. Sometimes it's easier just to pair them like I have done there, so you can get 81. Okay. All right, so do the questions I haven't done, check your answers and make sure you ask for help if you're having any trouble. But if you're okay with this, there's just some more work that you can do just for revision. But if you're planning on going on to do methods, you do really need to do the method stuff as well.